Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 10, Unknown Angle Proofs. Proofs with constructions. Okay, more proofs, more constructions. Opening exercise says, in the figure on the right, segment AB is parallel to segment DE. So, let's mark them. It's already labeled with the little arrow. So those two are parallel. And BC is parallel to EF. Segment BC, whoops, wrong choice. Segment BC is parallel to EF. Okay. Hint, extend BC and ED. So, I'll extend it. I'm just following the hint. So obviously they're saying extend this way because you want them to intersect, I'm assuming. All right, so there we have it. Okay, I extended BC and DE, or ED, until they crossed right here. Okay. So we want to prove that angle B is equal to angle E. Okay. So, remember with proofs, we always write down the givens first. So, segment AB, so we would just rewrite this. So I would say AB is parallel to DE, comma, BC, segment BC is parallel to segment EF. Reason? And let me draw this to block them. And the reason given. Okay. All right, so we need to label this point here. We have to give that a name. So we have A, B, C, D, E, F. How about G? So I'd call that G. Okay, let me move this in here. So what you see here are two parallel lines, the red ones. The blue is a transversal. Angle B and angle G, if we called that angle G, are congruent. So I would say B equals G, or the measure of angle B equals the measure of angle G. And the reason? Okay, so the reason is if parallel lines are cut by a transversal, then alternate interior angles are congruent. So angle B is congruent to angle G. And then we can say G is equal to E, angle E, lowercase. Reason? Okay, same. So I'm just going to copy and paste this. Okay, so now we're saying angle G is congruent to angle E because alternate interior angles are congruent. Okay, so if B equals G and G equals E, then we can conclude that B equals E. So and this is the transitive property, and I'll give an example. And there it is. So let's review transitive property. So I'm going to do that up here. Do you agree that 3 plus 1 equals 4? Is that true? Okay, so that'd be B. So if we call this B, and this G. Whoops. Okay, so we're saying B equals G. Now let's say G equals E. Okay, G equals E. 2 plus 2. So we can then conclude 3 plus 1 equals 2 plus 2. Do you agree with that? That is the transitive property. So if B equals G and G equals E, then B has to equal E. Okay, in the previous lesson you used deductive reasoning with labeled diagrams to prove specific conjectures. What is different about the proof above? Drawing or extending segments, lines, or rays, referred to as auxiliary lines, is frequently useful in demonstrating steps in the deductive reasoning process. Once segment BC and segment ED were extended, it was relatively simple to prove the two angles congruent based on our knowledge of alternate interior angles. Sometimes there are several possible extensions or additional lines that would work equally well. For example, in this diagram, there are at least 2 possibilities for auxiliary lines. Can you spot them both? So before you decide what to extend, you have to look at what we're trying to do. And we're told that AB, segment AB, you see a little arrow here and arrow here, AB is parallel to CD. We want to prove that angle Z equals angle X plus angle Y. So how can we draw an auxiliary line? So here's one way. Let me switch to dashed, thinner, and let's use green. So if I take this and extend it down like so, now I am forming a triangle here, and this transversal cuts all the way through both AB and CD, so I know that angle X is congruent to this angle right here. And then we can work from there. The other way, let's change colors, would be to have another transversal, or another, not transversal, auxiliary line that is parallel to both AB and CD. And we will do this on the next page. Okay, page 2 brings us to the discussion about these 2 different auxiliary lines. And so the first one shows the extension of this segment here down. And it says, here's one possibility. Given segment AB is parallel to segment CD, prove that angle Z equals angle X plus angle Y. Extend the transversal as shown by the dotted line in the diagram. Label angle measures V and W. So they created this V here, and they labeled this W. What do you know about V and X? Okay, well, for starters, let's answer that question. Angle V and angle X are corresponding angles on the same side of a transversal, both above parallel lines. They're called corresponding angles, and they are congruent. So I would say angle V is congruent to angle X. How about W and Y? So here's W and here's Y. Well, I'd say angle W is congruent to angle Y because they are vertical angles, and vertical angles are congruent. Okay. Now it says write a proof using the auxiliary segments drawn in the diagram to the right. So the first thing we want to start with is our given. Okay. So I'd say AB, segment AB, is parallel to segment CD. And the reason? Given. I just like to make this as neat as possible, even though my handwriting with this pen is not very good. Alright, so anywho. AB is parallel to CD, given. Great. Now what? Okay. Now you want to think about theorems that we've been using. This angle here is an exterior angle to this triangle right here. These are remote interiors. So V and W are remote interiors to Z, so we can say Z equals V plus W. Okay, and that's the exterior angle theorem. So we'd say the exterior angles of a triangle equal the sum of the two interior opposite angles. Okay. Let me erase these dots. All right, so what next? We can now use this here, and we can say x equals v, or angle x equals angle v, and that is corresponding angles. Okay, so if parallel lines are cut by a transversal, the corresponding angles are equal in measure. So angle x equals angle v. Okay. Then we can use the green one here. W is equal to y. So then we can say W equals y because vertical angles are congruent. Okay, vertical angles are congruent. And let's keep trying to keep this nice and neat. Okay, so now we have what? We have z equals v plus w. We have x equal to v. Z equals v plus w, x is equal to v. And we have w equal to y. What can we do with those? All right, so we could say this again. If we take z equal to v plus w, let me think about that. Okay, from this I can cut to the chase and say z equals, so here we have v plus w. So we know z equals v plus w, but then we can substitute in x for v. Since v equals x, I can replace v with x plus, and w is equal to y, so I can take this w and substitute in y in place of it because they're equal. So actually I should have drawn a segment from here. Since y equals w, I can put it there and then come to the conclusion that if z equals v plus w and v equals x and w equals y, then z equals x plus y. And that's what we were trying to do. And the reason is substitution property of equality. Okay? And then another possibility appears here. So this time they drew the auxiliary line here. And we are given AB is parallel to CD. Have to prove the same thing. But if we draw a segment parallel to AB through the vertex of the angle measuring z degrees, this divides the angle into two parts as shown. So v plus w equals z. So what do we know about v and x? So here's v, here's x, their corresponding angles. So I would say v is equal to x. How about w and y? Here's w, here's y. They are corresponding angles on two parallel lines. So we could say w equals y. How does this help you? Well, if v is equal to x and w is equal to y, then we can do that same substitution we did in the last problem. So if we now write a proof, again we're going to start with the same. We were told AB was parallel to CD. And the reason? Is given. Okay, and then the next thing we're going to do is say this. x equals v. Reason? Okay, so x equals v. If parallel lines are cut by a transversal, the corresponding angles are congruent. Okay, next step. Well, we can say w equals y. So w equals y, and the reason is the same. If parallel lines are cut by a transversal, corresponding angles are equal. Okay, then we can say z equals v plus w. Reason? Okay, angle addition postulate. V plus w equals all of z. Okay, and then we can substitute. And now we can say z equals, well, what does v equal? V equals x, so replace x with v. W is equal to y, so I can put y in place of w. So now we have what we're trying to prove, z equals x plus y. Reason? Okay, substitution property of equality, and we are done. So there's two ways to do this proof, and there's probably more, but there's two. Okay, page 2 brings us to a couple of examples. Example 1, it says in the figure to the right, AB is parallel to CD, so I made them orange. Even though there's little arrows there, I just think color helps. And BC, segment BC is parallel to DE because there's two markers on those. Is an auxiliary segment necessary? And the answer is no, because we have BC can act as a transversal. So let me extend it so you can see it better. So if we extend that, and if we extended the parallel lines, oops, let's try this. Okay, now can you see that DC extended and BA are parallel and BC it's transversal? So let's start the proof with our given. So we say segment AB is parallel to CD and BC is parallel to DE. Reason given. Okay. All right, next. Now I can say angle ABC is congruent to angle here. Actually, not there. We can do alternate interior. Let's go here. So angle ABC is congruent to angle BCD because of alternate interior angles. So angle ABC, the measure of, is equal to the measure of angle BCD. Reason? If parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Okay, so now we have ABC is congruent to BCD. Okay, well then if I focus on, now if I just make this back to where it was, and extend, make this a transversal with this, okay, and eventually you're not going to need to extend these, you will see it. So now we see that DE is parallel to BC and DC is a transversal. And now I can say, let me use green, this angle is parallel, or I'm sorry, is congruent to this angle. So that is BCD. So the measure of angle BCD is equal to the measure of angle CDE. Reason? same as before. If parallel lines are cut by a transversal and alternate interior angles are equal in measure. Okay. What are we trying to prove? We're trying to prove that ABC is congruent to CDE. ABC is congruent to BCD, and BCD is congruent to CDE, so now we can say the measure, let's change color, the measure of angle ABC equals the measure of angle CDE. And that's what we're trying to prove. So ABC equals BCD, but BCD equals CDE, then ABC has to equal CDE. That is the transitive property. Okay, transitive property. Okay, number 2. In the figure to the right, segment AB is parallel to CD. Okay, marked with red. And BC, segment BC, is parallel to DE. Okay, so the blues are parallel. Prove that B plus D is 180. So here's angle B, here's angle D. We have to prove they add up to 180 degrees. Okay, so how do we start any proof? With the givens. So the first thing I would say is segment AB is parallel to CD, comma, segment BC is parallel to DE. Reason, given. Okay. Easy enough. All right, so if I label this C degrees, because that's angles, this vertex is labeled C, let's call this C degrees. So now we have B degrees, C degrees, D degrees. If this is a transversal to these, then notice what's happening here. They're alternate interior angles. And if I look at this here, these are same side interior angles. So there's a bunch of stuff going on here. But let's go with, since this is marked with a green arc, I can mark this with a green arc because they're alternate interior angles. And sometimes if you extend a segment, you can see it better. If I extend this, I extend this, these two lines are parallel, this is my transversal, now you can see their alternate interior angles. So I would say B equals C. Reason, if parallel lines are cut by a transversal, then alternate interior angles are equal in measure. Okay? All right, so let me put this back. That was just to point out to you the transversals there. So I'm just shortening everything back to the original. Okay. But now I want to extend this and this, whoops, and this. And we're focusing on this transversal. So now we're making the red segment CD longer, and that's a transversal to BC and DE, which are parallel. And now focus on angle C and angle D. And when we do that, they're same side interior angles. So I can say C plus D equals 180 degrees. If parallel lines are cut by a transversal, then the same side interior angles are supplementary, which mean add up to 180 degrees. So now what we're trying to prove is B plus D equals 180. So if B equals C, I can now replace C with B and say B plus D. equals 180 degrees, because that's what we're trying to prove. Reason? Substitution property of equality. Okay, page 4 brings us to problem number 3, and we want to prove that D, angle D, this angle here, is equal to angle A plus angle B plus angle C. Given? Nothing. Okay, so how do we start a proof where we have no givens, we have no parallel lines, we just have a weird shape? Well, here's what I would do. Always look for triangles. So if I focus on one of the sides, thought I turned that to red. Let me see, red. If I focus on one of these sides, like right here, and I extend it, okay, so there's segment CD. If I extend that out beyond or to this edge, like so, then I form a triangle. Actually, two triangles. And that can be helpful. So we can label this. So if we have A, B, C, D, how about this is point E right here, and therefore this is angle E, degrees, right here. Now we have a triangle. Okay. This is an exterior angle to B and C. So I can start this proof by saying E equals B plus C. Reason? Okay, the exterior angle of a triangle is equal to the sum of the two interior opposite or remote interior angles, whichever you're comfortable saying. Okay. Okay, whoop-de-doo, now what? Now we know that B plus C equals E. Here is an exterior angle to this triangle. So E's exterior to this one, because it's this side extended. But then if I look at this triangle, this side's been extended. So now I can say angle D is equal to, let me change colors to blue. So now I have D right here. Well, that's going to equal the remote interiors of this triangle. So D is equal to A plus E. So D equals A plus E. Reason? The same. Okay? What are we trying to prove? D is equal to A plus B plus C. Okay, I see it already. What is E equal to? E is equal to B plus C. So can't I substitute that in for E? You betcha. So now I can say D is equal to A plus E, which is B plus C. How cool was that? So we just proved that D is equal to A plus B plus C. Reason? The substitution property of equality. So that was a really quick 3-part proof, 3 steps and done. Okay, page 5 brings us to the end of lesson 10. Hopefully you're getting more comfortable with writing proofs. Now go to your problem set.